Moving on to the first question. In figure 6.17, 1 and 2, DE is parallel to BC. Find EC in 1 and AD in second. Now moving on to the solution. Let us consider the first bit. Here he has given that DE is parallel to BC and he asked us to find the value of EC. From Basic Proportionality Theorem, we know that when a line is drawn parallel to one side and passing to two other sides of the triangle, then the line divides the two other sides in the equal proportion. So here from Basic Proportionality Theorem we can write that AD by BD is equal to AE by EC, which implies AD is 1.5 centimeters as given, divided by BD is given as 3 centimeters, which is equal to AE is 1 centimeter divided by EC, which implies, now as in the numerator and denominator centimeter and centimeter is common, that gets cancelled, and now by transforming EC or transposing EC to left hand side, we get EC is equal to 3 times 1 centimeter divided by 1.5, which is equal to, here 1.5 goes in 3 2 times, so we got finally EC as 2 centimeters. Therefore EC is equal to 2 centimeters in the first question. Now similarly for the second problem, by applying the basic proportionality theorem, as DE is parallel to BC, we get AD by DB is equal to AE by EC, which implies AD value has to be found and DB is given as 7.2 centimeters, which is equal to AE is given as 1.8 centimeters and EC is given as 5.4 centimeters. That implies AD can be obtained by transposing 7.2 centimeters on right hand side, that is 1.8 centimeter by 5.4 centimeters into 7.2 centimeters. Here in numerator and denominator centimeter is common and it will be cancelled, and here 1.8 goes in 5.4 3 times and 3 goes in 7.2 2.4 times, so which is equal to 2.4 centimeters. And finally now we got the value of AD as 2.4 centimeters. Moving on to a second question. E and F are points on the side PQ and PR respectively of triangle PQR. For each of the following cases, state whether EF is parallel to QR. Now moving on to the first bit solution. Data is PE is equal to 3.9 centimeters, PQ is equal to 3 centimeters, PF is equal to 3.6 centimeters and FR is equal to 2.4 centimeters. Now according to data, he says that PQR is a triangle and EF and E and F are points on side PQ and PR respectively. State whether EF is parallel to QR or not. From Converse of Basic Proportionality Theorem, if line passing to two sides of a triangle divides the two sides of the triangle in the same proportion, then it will be parallel to third side. So let us verify this. So let us take proportions for PQ, that will be PE by EQ, which is equal to 3.9 centimeters by 3 centimeters, which is nothing but 1.3 centimeters. And let us also find the proportions from side PR, which is equal to PF by FR, which is equal to 3.6 centimeters by 2.4 centimeters, which is equal to, here for 3.6 and 3.4, 1.2 is a common factor and 2.4 goes in 1.2 2 times and 1.2 goes in 3.6 3 times. So finally we get it as 3.2, which is equal to 1.5. Here centimeter is not there. Now as PE by EQ is not equal to PF by FR, this doesn't satisfy the rule that proportions of two sides divided by the line EF is not equal. So we can say that from Converse of Basic Proportionality Theorem, EF is not parallel to QR. Now moving on to the second bit of second problem, let us do a solution. Here the data given is PE is equal to 4 centimeters, QE is equal to 4.5 centimeters, PF is equal to 8 centimeters and RF is equal to 9 centimeters. Now let us consider a triangle. PQR with E a point on PQ and F a point on PR. Let's draw a straight line EF. So from Converse of Basic Proportionality Theorem, we can say that if a line divides two sides of triangle in the equal proportions, then the line will be parallel to third side. So let us verify that condition. So let us find proportion separately for the both sides divided by line EF. That is, proportion for PQ will be PE by EQ, which is equal to 4 centimeters by 4.5 centimeters. As centimeter is common in both numerator and denominator, that will be cancelled. And let us multiply the let us multiply numerator and denominator by 2 so that the proportion may be changed into simple form, that is 4 into 2 divided by 4.5 into 2, which is equal to 8 by 9. Let us also find the proportion for side PR, which will be equal to PF by FR, that is equal to PF is given as 8 centimeters divided by FR, which is nothing but RF, is given by 9 centimeters. So finally we get the proportion of PR is equal to 8 by 9. Here PE by EQ is equal to PF by FR. So from converse of basic proportionality theorem, we can say that PF is parallel to QR. Moving on to the third bit of second problem, let us note on the given data, that is PQ is equal to 1.28 centimeters, PR is equal to 2.56 centimeters, PE is equal to 0.18 centimeters, and PF is equal to 0.36 centimeters. Now let us consider a triangle PQR in which E is a side on P, Q, and F is a point on PR. So let us join them. It forms a straight line EF. So he asked us to state whether EF is parallel to QR or not. From converse of basic proportionality theorem, we can say that when a line passing to from converse of basic proportionality theorem, we can say that when a line passing through two sides of a triangle divides the two sides of the triangle in the equal proportion, then it will be parallel to third side. So let us check the proportions of both the sides intersected by the line, that is EF. Data is in terms of PQ and PR. Let us convert it into PE and EQ. Already he has given that PE is equal to 0.18 centimeters. Let us find EQ by using PQ is equal to PE plus QE, which implies 1.28 centimeters is equal to PE is 0.18 centimeters plus QE we need to find, which implies QE is equal to 1.28 centimeters minus 0.18 centimeters, which is equal to 1.28 minus 0.18 is nothing but 1.10 centimeters. And similarly let us find FR by using the relation that PR is equal to PF plus FR. That implies PR is 2.56 centimeters, which is equal to PF is nothing but 0.36 centimeters plus FR. That implies, making FR as subject, we get 2.56 centimeters minus 0.36 centimeters, which is nothing but 2.20 centimeters. Finally, we got the terms in PQ, PE, PQ. Finally, we got the terms in PE, QE, PF and FR. So now let's check the proportions. Here the proportion from PQ will be PE by EQ, which is equal to PE is 0.18 here divided by EQ, we obtained it as 1.1 centimeters. Now let us multiply both numerator and denominator to convert it into simple ratio. Then in this will be 18 by 110, which is equal to, here in 18 and 110, 2 is a common factor. So 2 goes in 18 9 times and 2 goes in 110 55 times, which is equal to 9 by 55 is the first proportion. Let us also find the proportion from PR, which will be equal to PF by FR. PF is given as 0.36 centimeters divided by FR, we found it as 2.2 centimeters, which is equal to, let us multiply and divide it with 100 so that it could be converted into simple fraction. We get, by multiplying numerator by 100, we get it as 36 and denominator will be 220, and here centimeter is common in numerator and denominator, that will be cancelled, and in 36 and 220 the common factor is 4, so 4 goes in 36 9 times and 220 goes in 4 55 times, so finally we get the proportion as 9 by 55. Here PE by EQ is equal to PF by FR. So from converse of basic proportionality theorem we can say that PF is parallel to QR. Moving on to the third question. In figure 6.18, if LM is parallel to CV and LN is parallel to CD, prove that AM by AB is equal to AN by AD. Now moving on to the solution. Let us note down the given information that LM is parallel to CD and LN is parallel to CD. So finally he asked us to prove that AM by AB is equal to AN by AD. So in order to prove this, let us consider the two triangles separately, that is ABC and ACD. If we consider in triangle ABC, he says that LM is parallel to CD. So from here we can say that if a line is parallel to one side of the triangle, then it divides other two sides of the triangle in the equal proportion from the basic proportionality theorem. So on applying this, we get AM by MB is equal to AL by LC. Nice. This can also be written as MB by AM is equal to LC by AL. As we need the proportion in terms of AB, let us add 1 on both sides. Then we get MB by AM plus 1 is equal to LC by AL plus 1, which implies here the numerator becomes MB plus AM by taking AM as LCM, which is equal to, here the numerator becomes LC plus AL divided by AL, which implies MB plus AM is nothing but AD whole divided by, let AM remain as it is, which is equal to LC plus AL is nothing but AC whole divided by AL, let it remain as it is. Let us rearrange the terms and we can write the expression as AM by AB is equal to AL by AC. So let it be as equation number 1. Now let us also consider in triangle ACD, LN is parallel to CD. Therefore, by basic proportionality theorem, we can say that AN by ND will be equal to AL by LC. Which implies, let us converse the ratio, then it becomes ND by AN is equal to LC by AL, which implies, let us add 1 on both sides so that we get the proportion in terms of AD. ND by AN plus 1 is equal to LC by AL plus 1, which implies, by taking AN as LCM, we get the numerator as ND plus AN whole divided by AN, which is equal to LC by AL. Let us take AL as LCM here, then we get it numerator as LC plus AL, which implies, here ND plus AN is nothing but AD and LC plus AL is nothing but AC. So AD by AN is equal to AC by AL, which implies, let us converse the ratio, then we get AN by AD is equal to AL by AC. Let us name it as equation number 2. In equation 1 and 2, the right hand side of the equation is equal, that is AL by AC and AL by AC. So we can equate AM by AD is equal to AN by AD. So which is the proof we require to prove. Now moving on to the fourth question. In figure 6.19, DE is parallel to AC and DF is parallel to AE. Prove that DF by FE is equal to DE by EC. Now moving on to the solution. He has given that DE is parallel to AC and DF is parallel to AE. Then asked us to prove that DF by FE is equal to DE by EC. In order to prove this, as he given that DE is parallel to AC, let us initially consider the triangle ABC and apply basic proportionality theorem. We get AD by DB is equal to EC by EB. And similarly, if we consider the triangle ABE and knowing that DF is parallel to AE, and by applying the basic proportionality theorem, we get the ratio in terms of AD by DB is equal to DF by FE. On equating this, we get a relation between DF, FE, DE and EC. So now, in triangle ABC, DE is parallel to AC. Then by application of basic proportionality theorem, we can say that DB by AD is equal to DE by EC. Let it be as equation number 1. In triangle ABE, given that DF is parallel to AE. So if we apply the basic proportionality theorem in triangle ABE, we get DB by AD is equal to DF by FE. Let it be as equation number 2. Now from 1 and 2, as left hand side in both the equations is equal, we can say right hand side will be also equal, that is DE by EC is equal to DF by FE, which can also be written as DF by FE is equal to DE by EC, which is a required proof. Now moving on to the fifth question. In figure 6.20, DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. Now moving on to the solution. He has given that DE is parallel to OQ and DF is parallel to OR. Now he asked us to prove that EF is parallel to QR. Now in order to prove that, if we are able to prove that PE by EQ is equal to PF by FR, then from converse of basic proportionality theorem we can say that EF is parallel to QR. So in order to prove that, we need to consider two triangles, that is POQ and POR, and by considering that ED is parallel to OQ and DF is parallel to OR and applying the basic proportionality theorem, we get the ratios of two sides, that is PQ and PR, in terms of PD and DO. So now let us consider two triangles, that is in triangle POQ and triangle POR by applying the basic proportionality theorem. As in triangle POQ, DE is parallel to OQ, the proportionality becomes PE by EQ is equal to PD by DO. Let it be as equation number 1. Now in triangle POR, DF is parallel to OR. So by basic proportionality theorem we can write PD by DO is equal to PF by FR. Let it be as equation number 2. Now as PD by DO is equal to PF by FR, let us substitute it in equation 1. Then we get PE by EQ is equal to PF by FR. Now it's clear that the proportion of PE to EQ is equal to proportion of PF by FR in triangle PQR. That means from converse of basic proportionality theorem we can say that EF is parallel to QR. That is from converse of basic proportionality theorem. Now moving on to the sixth question. In figure 6.21, ABC are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. Show that BC is also parallel to QR. Now moving on to the solution. He has given that AB is parallel to PQ and AC is parallel to PR, and he has asked us to prove that BC is parallel to QR. In order to prove that BC is parallel to QR, if we are able to prove that OB by BQ is equal to OC by CR, by converse of basic proportionality theorem we can say that BC is parallel to QR. Before that, by using the conditions AB is parallel to PQ and AC is parallel to PR, we can prove that ratio of OC by CR and OB by BQ is equal to PA by AO, and by applying the equality that we can obtain OB by BQ is equal to OC by CR, and by converse of basic proportionality theorem we can say BC is parallel to QR. So now let us consider the triangle POQ in which AB is parallel to PQ. So from basic proportionality theorem, if AB is parallel to PQ, then we get OA by AP is equal to OB by BQ. Let it be as equation number 1. And in triangle POR, given that AC is parallel to PR, so from basic proportionality theorem, we can say that OA by AP is again equal to OC by CR. Let it be as second equation. Now, substituting the OA by AP in second equation, that is OC by CR in first equation, we get the relation as OC by CR is equal to OB by BQ. Now, BC line segment is dividing OQ and OR in the same proportion. So, from corners of basic proportionality theorem, we can say that BC is parallel to QR, which is the required proof for us.